పైప్ తీసుకురా. హలో లైట్ పడుతుంది ఇప్పుడు వచ్చింది ఓకేనా. హలో ఇది ఉండాలి కదా లైట్. హలో hello everyone, welcome to ACE Online. Myself Madhushekar, faculty of ACE Academy. I am here going to discuss about SSC JE for mechanical stream. The Staff Selection Commission conduct junior engineering examination for various engineering positions in different government organizations. To work in those organizations, the Staff Selection Commission conduct the examination. So, the Staff Selection Commission conduct the examination with the two papers, paper 1 and paper 2. Both papers are computer based test papers. So, both the exams are conducted in computer. Now, if we talk about this paper 1, in paper 1 the syllabus is general awareness, okay, general awareness and general intelligence and reasoning. See, in this general intelligence and reasoning, they will ask you questions related to verbal, non-verbal relative questions like blood relations, okay, decision making, right, and some aptitude based type questions also they will ask you. And general awareness is like geography, polity, history, okay, political science, this type of question they will ask from the general awareness. And part 3 is mechanical engineering stream. Now, in this paper 1, okay, in this paper 1 for general intelligence and reasoning, that we can say in a simple aptitude, verbal and non-verbal, 50 questions, each question carry 1 mark. So, 50 questions, maximum marks 50. And for general awareness also 50 questions, each question carry 1 mark. So, maximum marks for general awareness 50. And the third one is mechanical engineering. So, from this mechanical engineering stream, they will ask you 100 questions, each question carry 1 mark. So, the paper 1 duration is 2 hours. So, total marks 100, paper 1 duration is 2 hours. If you get approximately more than 50 marks or even 50 marks, you will easily qualify this paper 1. Next, paper 2, that is also a computer based test. In this paper 2, it is totally a mechanical engineering paper. The questions they will ask from mechanical engineering. So, in paper 2 there are 100 questions, maximum marks for this paper is 300, and this paper duration also 2 hours. So, this is the scheme of examination, paper 1 and paper 2. Okay. In paper 1 general things, at the same time technical, in paper 2 pure technical. So, what I am saying, if you want to crack this exam, you should be strong in technical paper. If you are strong in technical paper, definitely you can crack this exam. Okay. Now, if you talk about this mechanical engineering, and here I am going to discuss within the mechanical engineering, I am going to discuss about the production technology part 2. In the last class, production technology part 1 was discussed by the Ravi sir. So, here I am going to discuss about the production technology part 2. In production technology, the syllabus is metal forming. In this metal forming, okay, in this metal forming, rolling, okay, drawing include wire drawing and tube drawing, extrusion, forging, and also sheet metal operations like blanking, punching, blanking, punching, deep drawing, and bending. So from the metal forming, they will ask you questions from these many topics. Okay, sheet metal operation and machining operations. See, in the syllabus explicitly it is given different machining operations. They are lathe machining operation, milling machining, drilling, shaping and grinding. And one more topic in the production part 2, that is metal cutting. So they will ask you questions from these many topics. As you know that the production is a huge weightage subject for the competitive exam. So for SSC JE also they will ask you good number of questions, at least minimum 20 questions in paper 2 they will ask you from the production technology. Now see here, we will discuss some of the expected questions from this part 2 from these many topics. One by one I will discuss these questions. Till now, is there any doubt, my dear students? Is there any doubt? So no doubt. So I will continue. Right. Now see here, in a sheet metal operation of 3 mm thickness. So this question is related to sheet metal operation. 3 mm thickness, sheet thickness is given 3 mm, sheet thickness is given 3 mm and a hole of 7 mm diameter. So in the question the whole diameter is given 7 mm, okay, needs to be punched. Hole of 7 mm diameter needs to be punched. The yield strength in tension of the sheet of material is 120 megapascal and its ultimate shear strength is only 100 megapascal. Tau u, that is 100 megapascal. So what is the force required to punch the hole? So we should calculate the punch force. Remember, in punching and blanking operation you can make a hole by using a shearing and tearing principle. So the material is failed by shear, so we should consider only a shear strength but not tensile strength. So now see here, the maximum punch force F max, maximum punch force is perimeter into thickness pi dt, perimeter into thickness, sheared area, that is into ultimate shear strength. Now see here, pi into diameter is 7 mm, thickness is 3 into ultimate shear strength is 100 megapascal, right. So calculator is not allowed for this exam. Without using calculator you should solve. See, it's a very simple question. Now see here, I am not converting the units mm into meter because this 100 megapascal is in, you can write it as, you can consider it as a Newton for mm square. So mm square means mm into mm. So I will get, so 22 by 7 into 7 into 3 into 100. Now see here, this one cancel out. So 22 into 3, that is 66 into 100. So 6600. Now you can take 6.6 kilonewton. See here, the option C is correct option. 6.6 kilonewton. 6.6 kilonewton. Without using calculator, with a simple basic formula you can solve this question. Right. Now the next question. Now the next question here it is. Listen, I will see the doubts. Is there any doubt? Now next question here I will explain. The next question is, see here, the initial blank diameter required to form a cylindrical cup of outside diameter d and a total height h having a corner radius r is obtained by using the formula. This is the direct formula based question. This question is related to the deep drawing. See, remember, from a blank, from a circular blank, remember the circular blank diameter is dB. From this circular blank we are going to make a cup. From this circular blank we are going to make a cup. In the question the data is given, the cup height is h, and cup diameter, outer diameter is d. So I want to calculate what is the initial blank size to make this cup. So you can use this principle, that is one side surface area of cup is equal to outside surface area, one side surface area of blank is equal to outside surface area of cup. Remember, you can use this principle, one side surface area of blank, one side surface area of blank is equal to outside surface area of cup. Outside surface area of cup. Outside surface area of cup. Now, one side surface area of blank I am considering pi by 4 dB square, that is equal to bottom surface area pi by 4 d square plus pi dh. So, from this you will get dB is equal to under root d square plus 4 dh. This is the general formula. That is the general formula, but in the question corner radius also we should consider. So, here out of these 4 options, the correct option for this question is A. A is the correct answer for this question. So, I am calculating this one by using a simple technique called area equivalence, like outside surface area of the blank is equal to the one side surface area of the blank is equal to the outside surface area of cup. Next, now see here, it is a match the following question, very simple question. In the list 1 process is given and in list 2 property is given. So, now see here, if you want to do a cold rolling, what property is required or what properties are going to be improved like this? Hardness, impact loads and wide drawing, indentation, ductility, malleability, resilience. Now, remember, indentation word is related to hardness, because hardness is the ability of material that can resist a scratch or indentation. Okay? Hardness is the ability of material that can resist a scratch or indentation. So, I am going with indentation. Hardness is related to indentation. Next, listen, resilience is the ability of material that can resist or that can absorb the loads, or sudden impact loads also you can take, right. And if we talk about wide drawing, ductility is very important parameter. So, S is 2, wide drawing S is 2, right. So, impact load I will go with the resilience, okay. I will go with the resilience, and to do the rolling operation, good malleability. Rolling is nothing but reduction in thickness and increase in length. So, good malleability is required. Now, we will check the options here. P equal to 3, Q equal to 1, P equal to 3, Q equal to 1, R is equal to 4, S is equal to 2. So, B is the correct option for this question. It is a simple question. It is a very, very simple question, right. Now, next listen. Right, no doubts. Now, listen, next. The ring rolling is used to, right. Right, okay. Now, see here, the ring rolling is used to, remember, the ring rolling is used to, now see here, this is a ring rolling operation, this is a ring. Now, this ring has more width. So, I want to reduce this width, okay, I want to reduce the thickness, you can say, I want to enlarge, increase the internal and external diameter. So, ring rolling is used to increase the diameter of the ring, either internal diameter or external diameter. So, ring rolling is used to decrease the thickness and increase diameter. So remember, A is the correct option. B is not correct because to increase the thickness is not correct. For producing a seamless tubes is not correct. For producing large cylinder is not correct. So ring rolling is used to decrease the thickness and increase the diameter. Decrease the thickness and increase the diameter. Decrease the thickness and increase the diameter. Now, next, the maximum possible draft in cold rolling of sheet increases with. This question is related to rolling. Okay, da? Now see here, in rolling, maximum possible draft. What is the formula for maximum possible draft? Maximum possible draft. Draft is nothing but reduction in thickness. Draft is nothing but reduction in thickness per pass. So delta H max per pass, delta H max per pass is equal to mu square R. Okay, delta H max per pass is equal to mu square R. So maximum possible draft, that is, now see here, delta H is directly proportional to the friction and directly proportional to the radius. Now see here, maximum possible draft increases with increasing friction, decreases with decreasing friction, decreasing rolling radius, increasing velocity. So A is the correct option for this question. A is the correct option for this question. Now see here, is there any doubt regarding this? Right. So 5 messages. Okay. Right, good. Now, next question, another question. A solid cylinder of diameter 100 mm and height 50 mm. Okay, na? Diameter 100 mm. Initial diameter I am representing with D naught. Height 50 mm. So height is 50 mm, is forced between two frictionless flat dies. So this question is related to forcing to a height of 25 mm. Final height is given 25 mm. What is the percentage change in diameter? Percentage change in diameter, not area. Remember, without using calculator you can solve. See, percentage change in diameter. Percentage change in diameter is equal to, okay, D naught minus df by D naught into 100. D naught minus df by D naught into 100. Now see here, D naught is 100, df we don't know, we should calculate that. Now see here, how can we calculate? In forcing operation there is no change in volume. So I can write here, listen, I can write here A naught H naught is equal to AF HF. Now we can write it as A naught pi by 4 D naught square H naught pi by 4 DF square HF. So D naught square H naught is equal to DF square HF. Now DF is equal to D naught under root H naught by HF. Now D naught is 100 into under root H naught is how much? 50 by 25. That you can say 100 into root 2, that is 141.4, because 414 1.414 na, root 2 value is 1.414, so 141.4. So 141.4 divided by 100, so that is nothing but you will get 0.414, so 41.4 percentage you will get. Simple question here, Very, very simple. Percentage change in diameter they are asking, but final diameter is not given, only the initial diameter is given. So, by using initial volume and final volume, I am finding percentage change in diameter. Next question. Cold working produces the following effect. Remember, in every competitive exam, there must be a question related to cold working and hot working. So, that is very, very important. Please go to the topic. Cold working is nothing but working the material below recrystallization temperature. Hot working is nothing but working the material above the recrystallization temperature. So, in case of cold working, strength and hardness increases, but in case of hot working, ductility and toughness increases. In case of cold working, more force and energy required, but hot working less force and energy. And also in case of cold working, dimensional tolerances are more accurate component can make compared to the hot working. But handling also easy cold working, but hot working is not. Right? These are the advantages and disadvantages of cold and hot working. But in cold working, the main drawback is residual stresses are induced because of the strain hardening effect, so that material become brittle. Stresses are generated. But in hot working, it is not like that. Ductility will increase. So, now see here, cold working produces the following effect. See, stresses are set up in the material, exactly correct. Grain structure get distorted, correct. Strength and hardness of metal decreased, that is wrong. By doing cold working, strength and hardness of material will increase, and the surface finish is also going to be improved compared to hot working. So, 1 and 2 are the correct. So, option A is the correct one. Option A is the correct one. Amen. Is it okay? Okay now. Now see there another question. The cutting force in punching and blanking operations mainly depends on. See, the cutting force, you are familiar, in punching and blanking, I already said to you, in punching and blanking, the workpiece material is failed by shear. So, the cutting force depends on ultimate shear strength of the material or shear strength of the material. So, B is the correct answer. The cutting force in punching and blanking depends on shear strength of the material. As you know that, I also gave a formula, maximum punching force is equal to perimeter into thickness pi dt into tau u, ultimate shear strength, because in punching and blanking the material is failed by shear. Next, in blanking operation the clearance is provided on. Remember, in blanking operation the clearance is provided on punch. One table I will give you that is very, very important. Remember, punching and blanking, punching and blanking. First one, clearance, clearance. Second one, shear. They will ask you questions from these two, clearance and shear. They will ask you questions from these two. Okay, simple basic questions they will ask you, that's why I am going to explain. In case of punching operation, the clearance is provided on die, and in case of blanking operation the clearance is provided on punch. But if we talk about the shear, generally the shear mechanism is used to reduce the punching force. So, if we talk about the shear, in punching operation the shear is provided on punch, and in blanking operation the shear is provided on die. So, this table is very, very important for every competitive exam. They will ask you this table. So, very, very important, be careful, especially like this SSC JE, RRB JE type of question, they will ask you. This table is very, very important. Now, a 2 mm thick metal sheet is used to be bent at an angle of 1 radian. So, they are going to bend at an angle of 1 radian. with a bend radius of 100 mm. So we are going to bend at an angle of 100 mm with bend radius is given 100 mm. Stretch factor is 0.5. Bend allowance we should calculate. Simple question. Bend allowance is equal to R plus K into T into alpha. R is the radius of the bend. Now see here, radius of the bend is 100. Radius of the bend is 100 plus 0.5 stretch factor. Thickness of the body is 2 mm into 1 radian bending angle. Radians given it is, so that I am not converting into, like I am not multiplying with pi by 180. In case in the question, if it is given degrees, you should multiply with pi by 180, but here it is not required. So 100 plus 1, that is 101 is the correct answer. Simple question. Next question. Now see here. Milling machine is classified as horizontal or vertical type depending on the position. Depending on the position of the spindle axle. See, based on the position of the spindle axle, okay, we are dividing the milling machines into horizontal milling machine and a vertical milling machine, so that the correct answer for this question is spindle. Next. The size of shaper is specified by. Remember, the size of a shaping machine is specified based on length of the stroke. Length of the stroke, we are specifying the size of the shape, how much stroke it is giving based on that. Next. In a taper turning operation, maximum and minimum diameters of the job are capital D and small d respectively. What is the taper angle? It's a very simple question. The taper angle is tan theta is equal to capital D minus small d by 2 into L. Length of a job is L, capital D is the maximum diameter, small d is the minimum diameter. So this is the taper angle formula. You should remember this one. So A is the correct answer for this question. Now, next question. The grit size of the abrasives used in the grinding wheel is usually specified by. Remember, the grit size is related to the mesh size. Grit size is related to the mesh number. You can say like 0 to 6, 6 to 8 or 6 to 14. Is it coarse grain structure or a fine grain structure? To know that, we are using the grit size in the abrasive material. So remember, the grit size is related to the mesh number. Now, the grinding wheel is considered better if the grinding ratio. So first of all, what do you mean by grinding ratio? What is grinding ratio? See here, volume of raw material removed. Remember, volume of raw material removed by volume of tool wear. Volume of tool, grinding wheel, tool wear. Now see here, very simple. Now suppose if volume of tool wear is more, means the grinding wheel wear and tear is more wheel material is removed. Is it good or bad? It is bad. Should purchase a new wheel. Always the grinding wheel wear resistance should be high, wearing of the material must be low. And if you want to increase the efficiency of the grinding machine, more workpiece material has to be removed with a very less amount of grinding wheel wear. So, for good or a high efficiency point of view, the grinding ratio must be high. Now see here, remember, listen carefully here, the numerator must be high, and denominator must be low. Numerator must be high and denominator must be low, so that grinding ratio is going to be maximum. Grinding ratio is going to be maximum. Maximum grinding ratio is required to do this grinding operation. Okay. Now listen, in which milling operation is the surface finish is better? So generally here you can see there are up milling and down milling, generally milling operations. Now see here, in case of down milling, remember the wheel is moving in this clockwise direction, and in the same manner the workpiece is also moving in the same direction. You can say the wheel is rotating like this, the workpiece is also rotating like this. But in case of up milling, the workpiece is moving in this direction, the wheel is rotating in this direction. They are moving in opposite direction. Now in case of down milling, starting of cutting will take place here. Okay, maybe on the surface here there may be some blur, some surface roughness is good, some cracks are formed, but next teeth is going to cut that material. Here there is a smooth surface finish is going to be formed, cutting uniformly. But here cutting will start here, removal of the material will take place like this. So you will not get a smooth surface finish here in case of up milling. So remember, down milling is the preferable milling operation to get a smooth surface finish. Down milling is somewhat efficient operation to get a smooth surface finish compared to up milling, because both are moving in the same direction, the workpiece and tool. So cutting will start at the surface of the workpiece material, but here it will not start at the surface of the workpiece material. So down milling will give you high efficiency. Down milling will give you high efficiency. Now the operation of finishing a drill hole to its right size is known as, remember, generally drilling is used to make a hole. Suppose I want to make 10.5 mm hole. Sometimes by using a drilling machine I may not make exactly a 10.5 mm. I may get 10.2 mm, 10.3 mm. It should not go beyond 10.5. So first what we are doing, rough drilling we are doing to make nearly that 10.4, 10.3 like that. Then after that, to make exact size, we are going with reaming, lapping, different operations are there, honing. So here out of these 4 options, reaming is the correct option. So remember, what is reaming? Reaming is nothing but it's like a drilling, but after a drilling operation, to make exact size of a hole, we are doing reaming operation. So A is the correct option for this question. Now next question. Now see here, which one of the following primary purpose do the flutes on a twist drill serve? So remember, for production most of the questions are theoretical type questions only for you. That's why I'm focusing more on theoretical type questions. Now here the question it is, its question is related to drilling. Now see here, which one of the following primary purpose of do the flutes on a twisted drill? Remember, what is the purpose of flutes on a twisted drill? Remember, twisted drills having like this, okay, flutes. So why are you providing these flutes? What is the necessity of providing flutes? Why are you not making a drilling tool like this as a cylindrical body? Why are you making flutes on a cylindrical body? The reason is, now see here what are the options given. They curl the chips for the easy removal of the chips. Exactly, this is correct. Remember, the flutes on a drilling tool is provided for the movement of the removed chips, removed material. So removed material float, move from bottom to the surface of the workpiece material. They are going to be removed. So easy removal of chips. It is not additional cooling. They will not give you aerodynamic design. They reduce the friction. No. So that is the first option is the correct one. So for easy removal of chips, We are using fist drills. Next, this is very important question here, spinning, because in let us consider, if you go to the kitchen, domestic utensils are there, na? Steel or aluminum panels, they are produced by this operation, spinning. Spinning is a sheet metal operation, but it is not a sheet metal cutting, it's a sheet metal forming. But we are using a lathe machine. That is interesting thing. Spinning operation is a sheet metal forming operation. We are deforming the material, we are making a cup shaped components by using lathe machine here. See, this is a lathe machine. We will keep the workpiece here and we will apply the portion. So, we will apply the force so that they are going to deform. We are applying the load less than ultimate point and more than yield point, so that they are going to deform. A cup shaped component is going to be produced. So, which of the following is a non-chip removal process? Non-chip removal process, we are not removing the material, we are not cutting the material, that is spinning on lathe. In case of milling, chip removal is there. In case of thread cutting, chip removal is there. In case of gear hobbing, also some amount of chip removal is there, but not in case of spinning on lathe. So, remember, A is the correct option. Spinning is a sheet metal forming operation. Sheet metal forming operation performed on lathe. Spinning is a sheet metal forming operation performed on lathe. Now see here, select the correct sequence of the following parameters in descending order of influence on tool life. So, remember, what are the parameters they are going to influence the tool life? The tool life, cutting speed, depth of cut and feed rate. Okay. So, out of these three, the most or first priority we should go with cutting speed, tool life, and then feed rate, then depth of cut. So, 3, 1, 2, 3, 1, 2. So, B is the correct option for this question. 3, 1, 2, B is the correct option for this question. Next, orthogonal cutting system is also called. Orthogonal cutting system is a two-dimensional cutting system. Remember, orthogonal cutting system is a two-dimensional cutting system. Now, see here, a steel bar of 200 mm diameter is turned at a feed of 0.25 mm per revolution with a depth of cut 4 mm. Okay. The rotational speed of the workpiece is 160 rpm. The material removal rate. See, it's a very simple question here. Material removal rate. Very simple. Feed rate into depth of cut into velocity. Okay. Material removal rate is nothing but feed rate into depth of cut into velocity. Now, see here, feed rate into depth of cut into velocity I am writing 5 dn by 60. Now, in the question, feed rate is given 0.25 mm, depth of cut is given 4 into pi into diameter is 200, speed is 160 rpm by 60. By solving this question, now see here, this one cancel out, right, and this one cancel out, right. By solving this question, approximately you will get 1675 mm cube per second. Okay, 1675. You can solve this question. Okay, na? Mm cube per second you will get. It's a very simple basic question. Now, see here, the next question here it is. A milling cutter having 8 teeth, number of teeth given in the milling cutter, 8 teeth, is rotating at 150 rpm, speed is given 150, if the feed per tooth is 0.1 mm, feed per tooth is 0.1 mm, the table speed in mm per minute. Remember, table speed in mm per minute, table speed in mm per minute. See the number of teeth into, okay, 0.1 feed rate into 150 rpm. So 120 is the correct one. 120 mm per minute. 120 mm per minute. Table speed is 120 mm per minute. It's a very simple question here. Formula also no need to remember. Just match the units. If you match the units, you'll get the answer. That is very, very easy question. If you match the units, you'll get the answer. Now, the next question it is, a super finishing operation which removes a little amount of material and produce excellent surface finish on the internal surface. Remember, after a drilling operation, if you want to increase the surface finish, if you want to remove the roughness of material, we should go with one process, that is honing process. Remember, honing process, not milling, not swagging, not trapping. Okay, na? Honing process is used to increase the surface finish of the body. Suppose this is a body, there is a more surface roughness is there. So I want to increase the surface finish by using this honing operation. So remember, honing operation, reaming operation, these are used to increase the surface. Actually, strictly speaking, reaming is to make exact size of a hole, but honing is not. Honing is mainly to increase the surface finish. Okay, na? So A is the correct answer for this question. Now, among the following machining processes, which can be used for machining flat surfaces? Remember, which can be used for machining flat surfaces in the question? Broaching is used to make hole. It's not used to make a flat surface. So very simple, broaching is out of this. So 1 and 2 both are correct. So by using shaping operation, by using milling operation, you can make a flat finishing surfaces. So A is the correct option for this question. Next, another question. What is the process of removing metal by a milling which is rotated against the direction of travel of the workpiece? Remember, milling is rotated against, remember, against the travel. Now, if you observe carefully, in case of down milling, this is milling or a mill gear and this is workpiece. Both are rotating in the same. This is rotating in the same direction of workpiece, but this is rotating in the opposite direction of workpiece. So, up milling is the correct answer. Remember, in a simple way, up milling opposite, down milling same. Otherwise, keep aside down milling, up milling opposite. In case of up milling, the tool and workpiece, they are rotating, they are moving in opposite direction. So, in case of this question, they are given against the direction of the workpiece. So that up milling is the correct answer for this question. Now, see here, which of the following is not a synthetic abrasive material? See, remember, the abrasive materials like silicon carbide, okay, alumina, like cubic boron nitride, silicon nitride, these are some of the abrasive materials. Here, which of the following is not a synthetic abrasive? That is silicon carbide. Silicon carbide is not a synthetic or man-made abrasive. You can make silicon carbide, you'll get directly from the earth also. So these are synthetic abrasive materials like tungsten carbide, aluminum carbide, titanium carbide, cubic boron nitride. So silicon carbide is not a synthetic abrasive material. So A is the correct one. Now see here, it is required to cut a screw thread of 2 mm pitch on a lathe. the lead screw has a pitch of 6 mm. Lead screw has a pitch of 6 mm. If the spindle speed is 60 rpm, then the speed of lead screw, very simple, remember, speed is proportional to 1 by pitch. Speed is proportional to 1 by pitch, right? So now I can take speed of the lead screw divided by speed of the lead screw divided by speed of spindle is equal to, okay, pitch of a spindle by pitch of a lead screw you can take. Now speed of lead screw is equal to 60 spindle speed into spindle pitch, you can take it as 2 by 6. From this you can take 20 rpm. Lead screw speed is lesser than the spindle speed, so 20 rpm. It's a very simple question, but if you know this relation, you will get this one. Very, very simple question. Easy question also, important question also this is. Now, the next question here, gear lapping. So what is gear lapping? See, remember, the gear lapping is also a surface finishing operation. Horning and lapping both are surface finishing operations. So these surface finishing operations, after doing machining, after completion of machining, after completion of heat treatment, there must be some scales formed during the heat treatment process. So we should remove those scales, we should increase the surface finish. So that's why, remember, lapping operation is a surface finishing operation applied after heat treatment. An operation applied after heat treatment, okay, to increase surface finish, remember. Now, which of the given below surface lay produced by knurling operation? Knurling operation. Now see here in this table, from this you will understand easily. Remember, planing operation you will get like this surface, parallel lay you will get. And shaping operation, shaping and planing, you will get perpendicular lay. And knurling operation, for a knurling operation you will get a cross lay. Knurling operation you will get cross lay, it is represented by letter X. And grinding operation, remember, multi-directional lay. Grinding operation, multi-directional lay, it is represented by M. And facing operation, remember, circular lay you will get. Facing operation, circular lay like this you will get, and radial lay this is. Okay. So in the question, knurling operation produce what type of surface lay? That is crossed lay. C is the correct answer for this question. C is the correct answer for this question from this table. Next question. Now, the method of producing large diameter holes without drilling complete material is not converted into chips. Suppose there is a big body is there, I want to make a large diameter hole. Generally, if I go with a drilling machine, more amount of energy is required, more material I should cut. So without cutting more amount of material, I should make a large size hole. That is possible with the trappening operation. I'll see here, you can understand. So suppose if I want to make a hole up to here, I want to remove this material completely. If I want to remove this material, no need to grind complete material, no need to drill complete material. I am using two teeth, hollow teeth I am using. So I am cutting the workpiece material here and here. So that we call it as trappening. Then counter boring is used to make or enlarging the hole. Counter boring is used to enlarging the hole. Counter shrinking is used to increasing the hole and making hollows, making tapered section of hole. okay, na countersinking. So now see here, method of producing large diameter, okay, without drilling complete material. So that is trappening operation. Trappening operation. B is the correct answer for this question. Now, which one of the following processing sequences will give the best accuracy as well as surface finish? Remember, the drilling is used to make a hole, but you may not get exact size of hole by using drilling. Rough drilling you can make. Then after that, reaming, exact size you are making reaming by using reaming. After reaming, to increase the surface finish, I am going with the lapping. Already discussed lapping. So drilling first, then reaming, then lapping. So C is the correct option. C is the correct option for this question. Okay, na? First drilling, making a hole, then making exact size of hole, that we call it as a reaming. Then after that, we are making excellent surface finish by using lapping. See here, drilling is for making cylindrical holes. Boring is for enlarging drilled holes. Reaming is to make finished hole or exact size of hole by slightly removal of material. We are not removing large amount of material, only some minute amount of material we are removing to make exact size. Lapping is nothing but surface finishing operation, so that drilling, reaming and lapping. Right, and continuous chips during machining forms when? Remember, continuous chip, when it is going to be formed? If the speed is high and feed is low. Feed must be low and speed should be high, so that you will get a continuous chip. High speed and low feed, you will get a continuous chip. So A is the correct option for this question. Now, in an orthogonal system, the cutting edge is, remember, in an orthogonal system, the cutting edge is perpendicular to the direction of tool travel. In an orthogonal system, the cutting edge is perpendicular to the direction of tool travel. So B is the correct answer for this question. So this is the basic information about SSC JE mechanical stream, and also explained about some of the expected questions for your exam. So if you want to crack this exam, you join ACE. We will support you in your learning journey. Okay, so all the best for your exam.